Alright, this video is going to be all about synthetic division, which is a shortcut to long division. Like shortcuts, the problem is that it doesn't always work, or it's just, not as good all the time as the long way of doing it, so that is the drawback. But otherwise, if you can use synthetic division on something, it's so much easier than long division. So up here on the screen, in some direction from where my head is right now, are some steps to how to do it, and probably these steps will make more sense once we've actually done a problem. But the idea is that we're going to take the x's out of this and just use our numbers to figure out what our answer is, because that it makes it seem a lot easier when there's just numbers and not x's. So if you want to read through those steps, that's fine, or if you want to write them down, but we'll go through a problem and those steps will make a lot more sense once you've actually seen a problem, probably. So here we go. One of the reasons we use synthetic division is we use it to figure out if something's a factor. Now on this problem, which was in an earlier video, in case it looks familiar, this problem is asking us, is x minus 6 a factor of x squared minus x minus 30? Well, x squared minus x minus 30 is actually pretty easy to factor, because you just have to say, well, what multiplies to get negative 30 and adds to get negative 1, and you split it up into two parentheses with x's, and those numbers that multiply to get negative 30 and add to get negative 1 go in the spots I have left. And so really easily, if you're any good at factoring, you should be able to say, okay, that's negative 6 and plus 5, and so we would say yes, that this is a factor. But another way of going about it, and this would be more helpful, I guess this strategy would be more helpful if it was something that we didn't know how to factor, is to use division. And so you can use long division to divide these, but we're talking about synthetic division in this video, so we can use synthetic division and divide these, and if it divides evenly, if there's no remainder, that's how we know that yes, it is a factor. So to set up synthetic division, you take what you're dividing by, which is x minus 6, and think about it like we're setting it equal to 0. If I have x minus 6 equals 0, and I work that out, that changes the sign of this, and that makes x equals 6. And that's the number that's going to go over here on the side. There's a couple different ways you can set up synthetic division, and this is one way, is that you put the 6 in a little bitty box over here. And then you put the numbers that are in front of our x's, and then the number at the end, you just put those numbers. So we'd put 1, negative 1, and negative 30. And then we draw a line underneath. The other way that you'll see it is people will put 6 and then make a box like this. And so if either of those look familiar to you, then, or whichever one of those look familiar to you, just go with it. What we do, whichever way we have it written, it doesn't matter. What we do first is we drop this first number, this 1, we drop it down. We don't change it in any way. It just automatically comes down here to the bottom. Then it's a series of multiplication and addition. I do 6 times 1 and get 6 and write it here. Then anytime I have two numbers in a column, I add those numbers together. So negative 1 plus 6 is 5. Then I do 6 times 5 and I get 30 and I write it here. Then I add negative 30 plus 30 and get 0. And so the answer to this is, I started with x squared, so it's always 1 power less. So this would be 1x plus 5 with a remainder of 0. The last number is always your remainder. So since they asked us if it was a factor, since we got a remainder of 0, we would say, yes, this is a factor, and we would know that x plus 5 is the other factor that goes with it. So that's how you do synthetic division, and I'll do a couple more problems in this video so that we can make sure that we understand how to do synthetic division. So just like with long division, we need to make sure things are in order on, like with what we're dividing, and so because this is not in standard form on top, then we need to start off by rearranging it. And you don't necessarily have to rewrite it, as long as you just do the next step in the right order. But I'm going to rewrite it. The 3w cubed has the biggest exponent, so it's going to go first. And then the w squared goes next. And then the w. And then just the number. So this is a division problem because we're trying to divide by the bottom, which is w plus 3. So I start off by saying if I set that equal to 0, what do I get? I get negative 3, and so that's what's going to go over here. Then 3, 7, negative 4, and 3. I'm just basically ignoring the w's and just taking the numbers from them. So we want to drop the first number and get 3. We do multiplication. Negative 3 times 3 is negative 9. 7 plus negative 9 is negative 2. Negative 3 times negative 2 is 6. Negative 4 plus 6 is 2. Negative 3 times 2 is negative 6. 3 plus negative 6 is negative 3. So I did that pretty fast, but it's a very repetitive thing. Once you've dropped the first number, you're just multiplying, write down, add, write down, multiply, write down, add, write down, multiply, write down, add, write down, until you've basically run out of numbers to use. Since we started with w cubed as our power, our answer starts with w squared. It's always 1 power less. So this is 3w squared minus 2w plus 2. Our remainder is negative 3, and so if our remainder is negative, we're going to put minus and then write 3 over what we divided by. If this was a positive 3, we'd put plus and then 3 over w plus 3. So this is supposed to be like something that we're subtracting or adding at the end. It's not just like written next to it without any sort of operation in the middle. So this would be our answer to this problem. Alright, this example is kind of weird because of the way it's written. And so it is a division problem because b plus 10 to the negative 1, this is just like what we used to do in Algebra 1 or maybe even in Algebra 2, where we might have gotten an answer like this, x to the negative 1 times y squared. And it's like it's a math thing to not leave negative exponents. And so what we did was we said, well, this x to the negative 1, we're going to move down to the bottom, and we'll give it a positive exponent whenever it's down on the bottom. So the same idea is happening here, and this isn't really super important probably to the rest of what you're trying to do, but just to set up the problem, we would move this down to the bottom so that it would have a positive exponent. And so whenever it's on the bottom, this is going to be b plus 10 to the positive 1, and since it's to the positive 1, we won't need to actually write it with parentheses. So all of this is just to say that this problem is a really fancy way for them to have asked us to divide b plus 10 into b cubed plus 75b minus 250. Once I know that that's what I'm trying to do, that I'm trying to divide, it's going to be the same kind of thing we did. We set the bottom equal to 0 and say that's a negative 10 that goes over here. The trick on this, though, is that they skipped over b squared, and so it's super important that we put a 0 where b squared should be. So it's going to be negative 1, 0, 75, negative 250. And you have to pay attention to that, especially on synthetic division. In long division, you can sometimes get away with forgetting to put a 0 as a placeholder, but for synthetic division, it's just going to screw everything up for you. So once I know that there should be a 0 in between the b cubed and the b, then I do synthetic division and get negative 1, 10, 10, negative 100, negative 25, positive 250, and then 0. So b plus 10 actually divides evenly into negative b cubed plus 75b minus 250. If they had asked us if this was a factor, we would say yes, because it divided evenly. And to write our answer, since they started with a cubed up here, we're going to start with squared. So negative b squared plus 10b minus 25 plus 0 is our remainder, but we don't need to write it since it's 0. So this is our answer. This one does not have anything like extra tricky about it, so this would be the case if you wanted to try to do this on your own. You can pause the video, try it on your own, and then press play to see what the answer is. So I'll go fairly quickly on this one, assuming that you've done that. So go ahead and press pause now. Okay, so this is going to be 4, 1, -1, -14, 11. Drop the 1, multiply and get 4, add and get 3, multiply and get 12, add and get -2, multiply and get -8, add and get 3. Our answer is going to be x squared plus 3x minus 2 plus 3 over x minus 4. And so that's our answer. One thing that we can do with this whole division thing is we can think about formulas that we use where division is helpful to solve. So if I am given this word problem, it says the area of a rectangle is 2x squared minus 11x plus 15 square feet. Now that's a really weird thing to have as an area, but let's just pretend that we know for some reason that we can write the area this way. And we also know that we want to write the length of our rectangle as x minus 3. What's the width of the rectangle? Well, we need to know that area is length times width, and that if I know the area and the length and I want to solve for w, that I would divide both sides by the length. So if my area is 2x squared minus 11x plus 15, and my length is x minus 3, then I'm going to divide these. And we actually know at this point a lot of ways to do that. Like I could factor the top into 2 parentheses and then see if the x minus 3 cancels with something on top. I can do long division or I can do synthetic division. So if I want to do synthetic division, I'm going to say, well, there's a 3 here, and then 2, -11, and 15. So I drop the 2. I multiply 3 times 2 and get 6. -11 plus 6 is -5. 3 times -5 is -15. 15 minus 15 is 0. So 2x minus 5 feet is our width. And I realize that seems really weird. It's not that we want to take this and set it equal to 0 to see what x is. We just want to say, okay, if I know, like the idea is that we could put in whatever we wanted for x and put it in here for our width and here for our length, and then we would be able to figure out what that would make our area be or something like that. Like we're saying that we don't know all the pieces, but if I could figure out what I want x to be, then I can figure out what all the rest of this would be as well just by plugging in. So that is synthetic division.